Oh,
These recordings. That's why I applied that now. See, it's around $30. Yesterday only I took it. Okay. Now see this. Uh, Reduction formula. You will have to apply. You'll have to apply the bypass formula here, Bhavya.
okay,
You have
sir.
to apply the bypass formula. So, uh, bypass, do you tell me please?
Integral u into dv is equal to uv minus integral v into du.
That's good. So, first we are deriving integral sine n x dx. Now, I will write it as IN, or IN stands for, the suffix gives you the power. If the power
Yes,
is
sir.
n minus 1, this becomes IN minus 1. Now,
Yes, sir.
to apply bypass formula, what is that I am doing? Sine n minus 1 x into sine x dx I wrote.
Okay, sir.
Now, integral, I want to apply UDV here, but for UDV, whatever the rule you have cannot be applied here because both are trigonometric only. So that's the reason why what I'm doing, I'm just treating this as V. Which one? Sin x.
Sin x
And whose derivative is sin x?
minus cos x.
Yeah, that's why to have more clarity, I have sent that sin x inside the derivative with integral.
Yes, sir.
Now it is nothing but integral sine n minus 1 x into derivative of minus cos x.
Yes, sir.
Is it clear, beta?
Yes, sir.
Now you tell me, integral UDV, apply that.
Minus cos x into sin power n minus 1 x minus integral minus cos x into
That I made it plus, minus of minus, I made it
n
plus.
minus.
Yeah.
Okay, sir. So n minus 1 into sin power n minus 2 dx.
One more term you are missing.
Sir?
One more term you are missing. Derivative of sin x is to be written now.
Yes, sir. Cos x into dx.
I made it as cos square x.
Okay, sir.
Now, this is minus cos x into sin n minus 1 x plus, bring that constant out.
N minus 1 into integral of cos square x into sin power n minus 2 x dx.
But what I did, just to see that.
Yes, sir. 1 minus sin square x.
Now, observe this clearly. What is that we started is IN.
Oh.
Now, this
In is equal to minus cos x I n minus 1. No.
no, not IN minus 1 because it is not including
Yes, sir.
integral.
Yes,
No.
sir.
Integral
Yes,
not
sir.
there.
Yes, sir.
If
Yes.
you have integral, you can say it as IN. Yeah, tell me.
Plus n minus 1.
Now you will get. Just see this. 1 into sin n minus 2 x
Yes, sir. So it becomes integral, it becomes I n minus 2 minus integral sine nx again, which is in.
I. That's good. That's good. Take it other side.
So we are left n into in.
No, this one. This one okay. This one okay.
Yes, sir.
Only entry.
On left hand side.
That's good. That's good.
Minus cos x into sine power n minus 1 x.
Correct? Huh?
Yes, sir.
So integral sine nth x dx is nothing but bring that n to other side.
Minus cos sine n power by n.
N is always greater than or equal to 2.
Sir?
N is greater than or equal to 2. In minus 2 now.
Yes, sir.
What I mean to say here, this power must be equal to 2 or greater than 2.
Okay, sir.
Are you with me?
Yes, sir.
Now this is reduction formula. How is it to be applied now? How is it to be applied? But before that, let us understand. Let us understand what will be cos nth x dx. You will be telling me.
Yes, sir.
Same beta, it goes like this only.
Sin x. So we'll get sin x into cos power n minus 1 into x.
Very good, very good.
By n plus n minus 1 by n in minus 2.
Very good, very good. That's it. Both the reduction formula we have got now. Correct? How
Yes,
to
sir.
apply that? Question. Integral sine 5th x dx is there, beta.
Yes, sir.
In place of n, what is that you have?
5.
5. Okay? Now, let us start writing that. Just know, you remember? This one you remember? Just memorize. You can memorize easily because we derived it.
Yes, sir.
Yeah. Come on.
So we get minus cos x sine power 4x by 5 plus 4 by 5 I3.
I3. That's good. Now I3 also we are not writing. We are applying the same formula for I3 also.
So minus cos x sine square x by 3
Yes.
plus 2 by 3 I itself.
I1.
I1. Yes, sir.
What is the meaning of I1?
Sine integral sine x dx.
That's it. What is integral sine x?
Minus cos x.
Done within one step about this. Just understand that.
So we don't have to further simplify those powers again.
Of course, Vida. But the answer, what is the simplification you get? Just multiplication of these constants and all. Multiplication of the constants only you will be getting. The major portion is, this is cos x sine 4th x, this is cos x sine square x, this is cos x. No similar terms are visible there.
Okay, sir.
So within one step we wrote that. You have to understand. But a thing is to be observed. What is that I am going to do now? I am introducing definite integrals now itself. I am introducing definite integrals now itself with this one. Like what, you know? But before that, if it is power 6 now, if it is power 6, what is the change you observe? If it is power 6 now, what happens? Finally, because it is n minus 2 here, you will get I naught instead of I1.
How, sir? It will be I4, no?
I4. And again apply the same formula for I4 also. You will get.
So we get I2.
I2.
And then we get I naught in the end. Okay.
That's what. What is I naught, you tell me?
X.
Yes. That's right. So finally, you will get into x if the power is even. You have to understand that.
Oh. Because we keep on subtracting 2 from it, so if it's an even number, we won't get I1.
Yes.
If it's an odd number, in the end we get I1.
Exactly. That's the reason why what happens when you have the limits 0 to pi by 2 now.
Yes, sir.
When you have the limits 0 to pi by 2, if the
we get minus pi by 2 in the end.
Pi by 2 in the end. Correct. If the power is even.
Yes, sir.
If the power is odd, you will get into 1. Because
yes, sir.
It is ending with either cos.
We get cos minus cos x. So
minus cos x with the limit 0 to pi by 2, no?
Yes, sir.
Then that will end with 1. So now itself we will write that definite integral formula after you write this. Like if the power is even, you will get into pi by 2. If the power is odd, you will get into 1.
Okay.
You want to copy that?
I copied it, sir.
Copied it. Very good. Now you got it now clearly?
Yes, sir.
That's good. Right. Now next, what I'm doing now, integral 0 to pi by 2 sine nth x dx is equal to integral 0 to pi by 2 cos nth x dx. Just read that, beta.
Integral 0 to pi by 2 sine power nx dx is equal to integral 0 to pi by 2 cos power nx dx.
That's good. Now, just what is the thing you have to do now? You just substitute it in the first term of the previous result. What is that you get? You tell me. What is the first term in the previous result, please?
Minus cos x into sine power n minus 1 x dx
Yeah.
Sine power n minus 1x by n.
Then if you substitute the upper limit and lower limit, what will be the term, you tell me? For upper limit pi by 2, cos becomes 0. For lower limit 0, sine becomes 0. The entire term vanishes.
Yes, sir. Yes, sir.
Entire term vanishes. Bhavya. So, in both the cases, what is that you have to understand? Whether it is sin nth dx or cos nth dx, in both the cases, first term vanishes. Correct or not?
Yes, sir.
Then what is that remaining, please?
Remaining n minus 1 by n, I n minus 2.
Very good, very good. Now, what is that we are doing with that? Just see now. So I'm not writing the first term because you understand that it becomes 0.
Yes, sir.
So n minus 1 by n into in minus 2, no?
Yes, sir.
So in the next step, n minus 1 by n into, replace n with n minus 2 now. Because we are now applying the reduction for this second part.
Okay, sir.
Tell me.
So minus cos x, sine power
No, beta, no.
n minus 3.
That's what. Minus cos x, no way it comes because it becomes 0 totally.
Yes, sir.
Yeah, tell me.
So we get n minus 3 by n.
N needs to be replaced with n minus 2.
N minus 2, yes, sir. N minus 3 by n minus 2 into I n minus 4.
Very good. Next step.
We get n minus 4 by n minus 3 I n minus 6.
Repeat. In this place you are right. This is the beginning.
N minus 1 by n into n minus 3 by n minus 2 into n minus 4 by n minus 3.
Wait. You have n minus 2 here. What is
Yes,
that you
sir.
have here?
I n minus 4.
So replace n with n minus 4.
Yes, sir. So n minus 5 by n minus 3.
Why 3?
Oh, n minus 4. N minus 4 into I n minus 6.
Yes. Now we don't write. We will write it in the sequence. Now you understand that there is a difference of 2 here.
Yes, sir.
And there is a difference of 2 here.
Yes, sir.
So what should be the next term?
N minus 7 by n minus 6.
Into so
Then
on
n
into
minus,
1.
yes, sir.
If n is odd. Into pi by 2.
If n is,
If n is even, this is
if
what?
n is even.
That is nothing but the formula for this. Come on, tell me the formula now.
N minus 1 by n into n minus 3 by n minus 2 into n minus 5 by n minus 4, so on into 1 if n is odd, into pi by 2 if n is even.
That's it. Hope you understand this.
Yes, sir.
Now I'll tell you an application here. Application. Integral of 0 to pi by 2 sine 10th x dx. Integral 0 to pi by 2 cos 11th x dx.
Oh, yes, sir.
Pi 10. Tell me the numerator.
9.
Yes.
9 into 7 into 5 into 3 into 1 by 10 into 8 into 6 into 4 into 2. So we get 2 also, no?
So what is that? You get 1 by 2 into what?
Into pi by 2.
Why?
Because the power is even.
That's good. Next.
Here we get 10 by 11 into 9 by 9 by no 8 by 8 by 9, 6 by 7 into 4 by 5 into 2 by 3
Into 1 beta.
Yes, sir. Yes, sir.
Correct, no?
Yes, sir.
So, do you understand now the application of it?
Yes, sir.
See how it is extended from indefinite to definite.
Yes, sir.
Clear?
Yes, sir.
So now we will move on to tan nth x dx. That is still easier than this. Still easier than this. You copied it?
No, sir.
Yeah. Come on, make it fast. You go to the next one.
Yes, sir.
Your father is there?
No, sir. They went out actually.
No one is there.
No, sir.
Because I spoke to your father, I never saw him. That is why I want to see him.
Sir?
I did not see your father, beta.
Oh. Yes, sir.
What is that voice? Some voice I'm listening to. Bhavya?
Sir?
Some voice I am listening from your side. Is it any?
Nothing, sir.
Huh?
Nothing, sir.
No, any TV is running?
No, sir.
No. Now this is integral tan n fixed dx. See, it is easy when compared to that one. Why? I'll tell you. Just this is in. Tan n minus 2 x into secant square x minus 1 dx. Tell me whether you understand it or not.
Yes, sir.
Then let us split this. Minus in minus 2, I say.
Yes, sir.
Correct, beta?
Yes, sir.
Now it is in the form of fx power n into f dash x. Just see that.
Yes, sir.
In plus in minus 2 is equal to fx power n into f dash x, please.
Tan power n minus 2x whole square by 2. Okay, n minus, yes, sir, yes, sir.
You said something other than
No, sir.
correct?
Yes, sir.
This was given in the previous examinations.
Okay, sir.
This was given. Now, if it is to be learnt in definite integration, how do we do that? Integral 0 to pi by 4 we take. I'll do one thing. I'll prepare a question here. I'll prepare a question in definite integration.
Okay, sir.
If in is equal to integral 0 to pi by 4 tan nth x dx, then find in plus in minus 2. Bhavya,
Yes, sir.
then you tell me how to proceed with the
So it will be tan power n minus 1x by n minus 1 from 0 to pi by 4.
Yeah. 0 to pi by 4. If you substitute the limits, what is that you get?
So what about the n value then?
This one now.
Yes, sir.
Now, you know its value. It is nothing but the same method we have to apply now.
Yes, sir.
Then when you apply this, for this one, the limits what you get is 0 to pi by 4.
Yes, sir.
That is in plus in minus 2 is equal to what is that you get? In plus in minus 2
is equal to tan power n minus 1x by n minus 1 from 0 to pi by 4.
tan n minus 1 x by n minus 1 within the limit 0 to pi by 4, no?
Yes, sir.
That's it, you substitute this. Tan pi by 4 is 1.
1.
1 power n minus 1, 1 only.
1 only.
And
The
tan
denominator?
that remains as it is, 1 by n minus 1.
1 by n minus 1. Okay.
So what is its value now?
1 by n minus 1.
That's it. That's it. You'll get the same question in definite integral.
Okay, sir.
You understand that?
Yes, sir.
Similarly, you can have the same simplifications for secant nth x and cosecant nth x and cot nth x also.
Okay,
I
sir.
derived 3 here: sin nth x, cos nth x, tan nth x. 3 more remaining. Cot nth x, similar model. Secant nth x and cosecant nth x is another model.
Okay, sir.
I'll derive secant nth x also. Okay. Secant nth x. Should I erase this?
Yes, sir.
వాయిస్ ఏం చెప్పలేదు ఎవరో మాట్లాడుతున్నారు. No, some voice is audible bit from your side. Maybe your neighbors.
Maybe, sir.
Oh, your neighbors. Very close, huh? That your neighbors' voice is audible.
Yes, sir.
That's what. Okay. Now see here.
Yes, sir.
Secant nth x dx beta. Secant nth x dx. Secant n minus 2th x into secant square x dx. Okay?
Yes, sir.
Then, do you tell me any idea? UDV only. What is integral of UDV?
UV minus integral V du.
So which one should we take as V? Whose integral is known to us is to be taken as
Secant square x is the derivative of tan x.
Yeah.
So we take that as V.
Yeah.
So we take tan x as V.
Okay. Then apply reduction. Apply the reduction now. Now it becomes integral secant n minus 2th x into derivative of tan x as you said.
Yes, sir.
Come on, tell me next step. Tan x into
secant power n minus 2x minus integral tan x into n minus 2 secant n minus 2x n minus
3x
n minus 3x
into secant x derivative again.
Yes, sir. So we get tan square x.
And also secant n minus 3 becomes secant n minus 2.
N minus 2. Yes, sir.
Minus of n minus 2 integral
N minus 2 into
let us write this now as 1 plus secant square x minus 1.
yes, sir.
Then that secant square x minus 1 into secant n minus 2 x, no?
Yes, sir. So we get
In again.
n minus 2 into in minus n minus 2 into
minus of minus plus. Plus.
Yes, sir. So plus n minus 2 into in.
In minus 2.
Yes, sir. In minus 2.
Bring this to other side.
So in plus no.
1 plus n minus 2.
So n minus 1 in.
Yes, yes, yes. That is right now, strike. So if you transfer this to other side, n minus 1 remains, no?
Yes, sir.
Bring this to the denominator.
So we get tan x into secant power n minus 2x by n minus 1 plus n minus 2 by n minus 1 in minus 2.
That's it. Done, beta. Can you imagine similarly for cosecant nth x?
Minus cot x cosecant n minus 2x by n minus 1 plus n minus 2 by n minus 1 in minus 2.
That's good. That's good. Very good. Similarly for cot also you can imagine.
Yes, sir. We get in plus in minus 2 is equal to cot n minus 1 x by n minus 1.
Minus cot. I think minus cot must be there.
Okay. Minus cot power n minus 1 x.
So instead of 1 by n minus 1 as in the previous case, you will be getting 1 by 1 minus n, I think.
Yes, sir.
Is it clear, beta, reduction?
Yes, sir.
Now finally, one difficult reduction is remaining is the product of sine and cos.
Okay, sir.
Charging. Should I erase this?
Yes, sir.
We'll be taking it as I m comma n.
Okay, sir.
Okay?
Yes, sir.
Now, I have to again apply by parts. You have to follow this carefully, beta. You have to follow this carefully.
Sir?
I have to again apply by parts only. So you follow this carefully. What is that I did? Yeah,
Something
Bhavya.
went wrong with the internet connection, sir.
Yes, yes. So now very rarely it is happening because we both are on the same network. It is very rarely it is happening.
Yes, sir.
Previously, for the past 3 years, I've been doing this now. Generally, it occurs at least 3 to 4 times in 1.5 hour, 2 hours. Now, can you read that, beta? Second part.
Integral sine power mx into cos n minus 1x into cos x dx.
Now, do you tell me the idea how to create dv here?
So,
We have to
how
create
to create
udv, no udv.
dv? Mm. Cos x is the derivative of sine x.
Very good, very good. You're on the track. What is that I did? You see? You understand it, beta?
Yes, sir.
Why? It is in the form of fx power n into f dash x.
Yes, sir.
Integral cos n minus 1 x into derivative of. Come on, tell me now.
Derivative of integral sine power mx into cos x. So it will become derivative of sine power m plus 1x by m plus 1.
By now you must have understood why I'm doing the derivative of integral.
Yes, sir.
To create
Because it's not easy to predict for every term.
That's what. If it is simple term now, we can easily say.
Yes, sir. Yes, sir.
Now apply udv.
Sine power m plus 1 by plus 1 into cos power n minus 1x minus integral sine power m plus 1 by m plus 1 into n minus 1 cos power n minus 2 sine x dx.
That sin x we will add it here.
M plus 2.
And minus we will make it plus here. You might have, by now you might have understood whatever the term we are integrating in the beginning, the same term we are getting in the simplification with minus in RHS.
Yes, sir.
Thereby we are transferring that term to LHS and getting it integrated. We are getting a reduction formula from that.
Sir, how did we get plus over here?
As you said, sin x derivative is minus cos x now.
Okay. Yes, sir.
So cos x derivative is minus sin x. Cos x derivative is minus sin x. That's minus of minus plus.
Yes, sir.
I'll write a direct step. You just understand it, beta. N minus 1 by m plus n. I bring that out.
N minus 1 by m plus 1
Now we write it in this way. Sin mx divided into sin square x. This is sin.
Yes, sir. So we write that as 1 minus cos square x split with the cos power n minus 2x.
Yes, yes. Okay? Then what
Yes,
happens? You will get n minus 1 by m plus n. The sin mx, sin square x is 1 minus cos square x. So you will be getting I m comma n minus 2. Its power is written here. Minus of n minus 1 by m plus 1 into I m comma n. The same term repeated now.
Yes, sir.
This will be transferred that side. Okay.
Yes, sir.
To get the final result. You do one thing. Take the Telugu Academy textbook and finish up the last exercise. Last exercise is involved with this one only. Reduction.
Yes, sir.
Reduction formula. To finish up that last exercise.
Okay.
From the academy text. So I am not concluding it because you understand now what is to be done next.
Yes, sir.
Now similarly, if you have integral 0 to pi by 2 to this now.
Yes, sir.
It is very much similar to the previous only, but the power is m plus n here. But the total power is m plus n now.
Yes, sir.
That is why denominator starts with m plus n. And numerator will be m minus 1. And it reduces by 2.
Minus 2. Oh.
And so on. And so on. And so on. It ends. And again n starts.
N minus 1 into n minus 3 into n minus 5, so on.
Continues. Into 1. Into pi by 2. If both even. Into 1. If otherwise. What is the meaning of if otherwise, beta?
If both are odd or if one is even and one is odd.
That's it. If both are even, what should it be?
Into pi by 2.
That's it. That's it. I'll take an example. I'll take an example. Integral 0 to pi by 2 sin 4th x into cos 4th x dx. Please read
Yes,
that
sir.
once. Read that.
So we have to multiply it with pi by 2.
That's good. That's good. That's good. What should be the denominator? 8.
8.
Numerator?
3.
Reduce by 2.
1 by 6.
But ends.
Now we have to start reducing n again. So again 3 into 1 by 4 into 2
Into
pi by 2.
Done, please, done. Bhavya,
Yes, sir.
are you with me?
Yes, sir.
These are reduction.
Yes, sir.
Hey, Fataka.
Yes, sir.
That's it.